So under this recording, we'll be doing compiler theory and data structures. So we've done the introduction already, but I'll just re-explain some of the things. We've discussed what is a compiler on the last class. We said, let me check this one. It says a program that accepts an input as a program text in a certain language and produces an output text in another language. A program that reads a program written in one language and translate it into an equivalent language, right? We give two definitions. We also give our own definitions here in class. We said a compiler converts the human written code, right? Just say encode into a machine code. So you can define compiler in many ways, but this is also one of the definitions, and it's quite simple and easy. So you must just define it in easy way, or you can decide to take this one. It's also fine. Convert one language, which is the source language, and then into the target language, or you can say machine language. So we know that your source code will be converted, will be read by the compiler, and then our compiler is going to change everything into a machine code or a machine program, which is what we can also call target programs. And then also defined an interpret. It's a program that reads a source program and and produces the result of executing the source. So we said, and the most important thing we said in class, we said it translates, it reads the code line by line. An interpreter, it reads the code line by line. So this is what you'll tell them, especially if they ask for the difference. But if it's just the definition, you can just say it's a program that reads a source program and produces the result of executing this program. But most importantly, should include this. I think you can plug that into the definition and say it reads the code line by line. Then yeah. Then this is the procedure from source program to interpret, and then the interpreter interprets. For a compiler, you saw that here we write compiler, right? So that's there, and then here you say output, or you'll say machine target program for when you are writing for the compile. You already know how to construct these simple diagrams. And then we'll talk also about the qualities of a compiler. We said it should generate the correct code, generate the fast code. It must let's see, here they say copies with essential arbitrary input size variables, but I want you guys to know these ones because they are very easy to remember. Right? Copies with essential input size, no, not compilation time 5 6 cine. Yeah, I can just note these ones. They say it generates correct code, generate fast code. The compilation, a compiler, it reduces what the compilation time. It's short when you are using a compile. When the compiler is converting your code. Remember, a compiler will convert your source code all at once. It doesn't read line by line. It just takes everything. Once we have got processes of a compile, the steps, we'll check them. Principles of compilation. They say a compiler must preserve the meaning of the program being compiled. Okay, this you already know. Uses of compiler technology. You know that compilers, they are used to improve what programs performance. That's one of the things you should know. And they also provide safety of programs. So and then also talked about the major parts of a compiler: analysis and synthesis. Then I said you should know the difference between these, right? So this one is used on front. We are talking about the front end part of your compiler. And then with synthesis, we're talking about the back end of your compiler. You see, in synthesis phase back end, the equivalent target program is what is created from this intermediate. So these are the steps: intermediate code generator, code optimizer, and then on analysis part, which is the intermediate representation created from the given source program. It breaks the source program into these parts. So this is the first 3 steps of the compile: lexical, synthesis analyzer, semantic analyzer. Those 3. These are the parts of the front end. So also explain how they work. So this is the difference. Remember, I asked you guys the difference. You'll say analysis is the part of the source program, and then this one. So when we talk about analysis, this is the part. You see, it's divided into 2. So this is the part where your program will read, your compiler will read the source program and analyze it, and let's just say and do analysis. And then on synthesis, this is part of the program where your computer is going to check, to convert and synthesize. You see, ne? So these terms are very easy to understand. And synthesize your source program to machine code. Is like that. Then we move now. We talked about this, that it can be broken into tokens. We have got 1, 2, 3, 4, 6. Then we said we're gonna write them like this. And then you'll see equal sign. I'm including everything here. Then you separate them with a comma, right? This is when now you are writing this as a what? As a set of tokens. Then I think we have there's a difference between a token and a lexeme. Go down. It reads this. Okay, lexeme, they say they read the stream of characters and group them into meaningful sequences. So when you write it like this, for each lexeme, it produces the tokens. So that statement there, okay, let me find you guys an example of. So this whole statement here, it's a what? It's a lexeme, right? But the moment you start writing it like this, I was looking for this. Now you call this tokens. So when it's still like this, let me go back. When it's still like this, this is still the original part. I haven't converted anything. This is still what? A lexeme. Then the moment I say ID1, then ID1 is position, and then the operator, to leave it like that, plus initially it will be ID2, and then you have got as a multiplication. So this is just a recap. We've already done this. So from here, moving to something else. Then here you will say rate, and then you have 60. Yeah, so this is a set of tokens. Now the structure of a compiler, we've talked about this. We say the first part, scanner, it's lexeme, it's lexical analysis. And this one we said it's what is the semantic, another name is semantic analysis. Then we've got semantic, and then the next part is optimization. The last step, I think the left one, they should have also included day 6, 1, 1, 2, 3, 4, 5. Yeah, they were supposed to also include the intermediate code generation. So this one, its duty is to improve. It improves the optimization process. So let me try to explain this here. So I'm going to explain the structure of a compiler. Let's just explain this here. Then we have lexical analysis. That will be the first one that I'll explain. After this, we're gonna switch straight to data structures. After I'm done with this introduction, we'll also do the introduction to data structures. Lexical. So we're going to start with the front end. The lexical analyzer. This one, obviously, we're talking about the conversion of the source code into tokens. This is where the compiler will convert your code into a set of tokens. So you must know what tokens consist of as well. We know that they consist of keywords. So these things I've already explained there. Just giving you guys a recap. It consists of keywords, identifiers, operators, numbers, literals, and symbols. Let me just write this. Identifiers, operators, numbers. Let's also say, and symbols. Let's write this code down, then we'll check. Main int I j. Then I'm gonna create a simple for loop. I plus plus. Then print. I just say print f. That's what they wrote. So we can write it in Java. Steam dot print dot out dot println. Then here I'm having I initialized to I. Okay, so obviously main, it falls under what? Keywords. These are our keywords. And then we have operators. We're talking about plus, less than, plus, plus. Then we're talking about, when we talk about numbers, 0 here would be our operator. Symbols, this one is part of symbols. So this is what we mean. It will convert your source code into a set of what? Tokens. That's the first part of the first phase, right, of compilation. And then now, which is the lexical analysis. Then on the second part, which is the syntax analysis, or let's also have this one. It's also a nice example. Int x equal to 5. And then this is your code, your line of code. When it divides this into tokens, it will be int x 5. So you see, it will divide it like that. So let's go to the second phase, which is the parser, or I like calling it the syntax analysis. So with this syntax analysis, we're going to have, this is where your program checks the grammar. First thing it will check is the structure correct. Correct. Is the declaration correct? Correct. These are the questions that your compiler will be asking on the syntax analysis phase. So let's say you're leaving int x equal to 10. It's going to check if this is correct. If obviously if here it's Boolean, this will be wrong, but it has to be, the corrected part will be int x is equal to 10. Yeah, like that. And then now on the semantic, it checks the meaning of your source code. Semantic analysis. So this is still the introduction. This, it checks the meaning. It also checks on your lines of code the type check E. This is similar. It will also check the variables that you used, if they are correct or not. If the declaration of variables is correct, variable declaration, I'm going to say checking if the variable declaration is correct. Then it will have something like, can say int of y, then you see x is equal to hello. Already here there will be an error because this variable was not what declared. So here we will have an error message. Then we go to the intermediate. Code generation. So on this part, the compiler will generate a machine independent intermediate form, right, of a code. Let me write this statement. Generate a machine independent. So this time it's important. Independent intermediate form. Intermediate code. Let's just say it like that. So let's say previously we're having int x equal to 5, isn't it? On my previous example. So on this step, it's going to store 5 on T1. It will create its own code, and then it can initialize, it can create a new variable. Your compiler will create a new variable. So this statement is still, the meaning is still the same. Just that now we're now doing the what? Remember from intermediate, check. We said we have the synthesis and the analysis. So on the synthesis, that's where we start talking about the intermediate code generate. So your computer already now, the compiler now creates its own source code. That's why they say independent for. And now let's move to the next phase, which will be code optimization. Here it improves. The compiler improves the intermediate phase, the intermediate synthesis code. So if you had x equal to 2 plus 3, it will be optimized to this. Let's say it will optimize it to x is equal to 5. You see, ne? Or if you had x is equal to a 3, then you say y is equal to a, what can we write here? I'm going to create something, or let's use a string. Let's say you said x is equal to bongs. Then here you say bongs is Java. Although it doesn't make sense, the aim is for you guys to understand x plus y bongs is Java. Isn't it? You'll have this. Well, now you combine the strings. So now on the optimization part, it will just say that stores everything. Bongs is what? Is Java. You just write the results. So now on there, we'll go to the what? The code generation. Oh, this one it doesn't. Oh, I said it, yet it produces the result. It won't exactly do the result. Okay, but yeah, it's the same thing. It has optimized that code, isn't it? And I've got code generation. Now this one, the final output is produced. So you guys, you have to remember now that when we go to, remember the concept of NFA conversion to DFA. You have to know that here on this one, we're going to apply the optimization process. Because we're going to create a syntax trees. Let me just say transition diagrams. But we're not yet there. So I think maybe I'm going too fast. Let me skip that for now. Then let's go to, I want us to discuss important things, right? What we created. Okay, I've already discussed the front end and back end. The front end, we have the lexical, syntax, and semantic backend optimization and code generation. Okay, so I believe that you guys by now you understand. And then I've explained that with tokens, you will just have a set of symbols divided like that. So now let's discuss. I think we should discuss the lexical analysis a bit. Let me go to a slide. think it can help us to actually finish this quick. Yeah, let's go to this slide. Now, this one. Yeah, let's use this slide. We've already done this, right? So the last class I gave you guys even this example here. Here they were converting this into what? Into tokens. So they are saying lexeme. So okay, lexeme is one. Each letter you call it an exeme while it's still like this. But the moment we change this code, into ID1, comma, equal sign, ID2. Remember, I'm focusing here, right? ID1, ID2, ID3. Then the next symbol is multiplication. And if you check, this is just MC squared. They just wrote it in a form of, yeah, like that, times 2. So I've already explained this, so I think I should skip this part. And then they are saying we've got what we call specification of tokens. We use the regular expression in order to formalize tokens. And then they say example, letter, digit, or can say, so digit can be zeros and ones. Let me find an example here. Let's say you have 0 letters, any letter, right? Any letter, asterisk. So, but usually we'll be using epsilon, you see, ne? So this is the format of regular expressions. Move, we've talked about epsilon on the last class. See, this is an empty string. Okay, well, let's move. So we have what we call operations on strings. We have concatenation. So with concatenation, we're talking about multiplication. XY represents the concatenation of strings X and Y. So this is just multiplication. And then we have an example here of concatenation. S times epsilon is equal to S times E. S to exponent n, it's S up to infinity. S0. So these are just the basics. So S to exponent 0, it's not 1, but it's epsilon. Yeah. So these are just the rules. So with concatenation, just have to note multiplication of your string L1, L2. Remove this. Then union is the union of what? Of this string and that string. So it's S or S element of L1, or S is an element of L2. This is just to take care of also L2 when they say or sine. Then with exponential, it will be L0 epsilon. Then, but if it's L, you guys, you know this from mathematics, this is equal to 1. So here it's not, it's equal to the set of epsilon. Then this is L squared, it's LL. So I've given you guys an exercise, but it's fine. I will discuss that contact. And then you have this I equal to 0. This is the clean closure. We've talked about it. This is the asterisk that it's used for representation of strings. I gave you guys an example on the last class, I think. Let's check here. They give us, given that you have L1 asterisk, you have L1 being initialized to this set of strings A and B. So with L1 asterisk, this will give us A, B, A. You see, you can arrange this as many times as you want. You can have BB. You can even repeat BB as well. BBB, A. So this represent what? Repetition. Then we said we include epsilon for the ones that repeat. So meaning that I should include epsilon. But for L plus, if it was plus, so it's still the same thing with plus. With L plus, the meaning remains the same, repetition as well. So this one, it doesn't include epsilon. So the regular expression will be defined in this way, etc. So now let's go to these were talked about it as well. Then you see now, even with 0, it will be the same thing. Then 0, 1, 0 or 1, the result is just 0, comma 1. And write it in a form of a set. So you can also go and try doing this, or they already did the answer there. So this one, it will always, I give you guys a question. I said, let me copy those examples here. I give you guys a regular expression. I said go and define now. I wanted something like this, and also a bit of explanation of what will happen. So let's do it. I'm just gonna remind you. Let me just do one of these. So I give you guys something like this as an exercise. One, they say describe the language defined by the regular expression. So this is what I wanted. I give you it's A of B after A 2 epsilon or A asterisk after. Let's just try the first two. With number one, we can start with an A and have a combination of A and B, right? A, B. We can stop there. We can have A, B, A, B. We can have what? A, B, A. Can have A, A, B, A, B. A, B can be repeated as many times as you want. So I'll just do this. So I wanted you guys to say the regular expression. It will always begin with A and with what? With AB. Challenge. Oh, this one should be AB. It will always end with AB. And it will always do what? And remember, we can also have, let me see, we can also have A alone here. Can neglect this part. This part is possible for the first. Let me also check here. 0 or 1. Even here, you see, we are allowed to say 0, 1, and then 0, 0, 0, 1. Even here, we can say we have A, we have B, you see, and then you write the other things. But obviously, your string will always, here we cannot say B only because you must always start with B. So we can have A alone. Always begin with A, and then neglect the other part. Then with number 2, with this one, can have epsilon, can have A, because it's saying A or B. Can have A, B, A, B, B, A, B, B, B. So this one, it will always, your string will always, and remember, we can also repeat, this part, meaning you will have A, B, A, B. You can also have A, B, A, B, A, B, A, B, A, B. See, so with this one, you can explain it like this. My string will always start with, can start with A always, but it can also alternate between A, B. We'll say start with A always, and we're allowed to repeat A, B. You'll also try to find a better way to write this. And then let's see other examples here. Okay, these are a set of letters, these are a set of digits. They are saying a regular definition gives names to a certain regular expression and uses those names. This is not really important. I think we're done with this slide. This you already have. We've done such things, but let me explain this. The first two, you guys will check the other ones. Or the first three. So the first expression here, this is a set of 0, 0, 0, 1. You are allowed to convert this so that they are equivalent. And then when they say 0 plus, you can begin with a 0, with a 1, you can have a 10, you can repeat, you can add a 0 there because this 10 is repeating. It's 100, 1000, that way. With this one, if you start with 1, 0, 1, you can alternate between 0 and 1. This the repeats. So your string always ends with what? If you check, it always ends with 10, unless if you are only checking the first few. But if this continues, it will always end with 10. So that's how you must define it. This one, they say describe, will always end with 10. And also, okay, this one cannot repeat. Let's check this one. They say this is equivalent to that. You can have either a 0 or an epsilon, or a 1 and an epsilon. Hence you have got epsilon 0, 1, 0, 0, 1. It's when you combine this and that. So this is quite easy. Just have to practice. So let me go to lexical analysis continuation. I think this one I'm gonna skip because I don't want to teach you guys NFA and DFA yet. But let me first teach you a bit of this so that you can have an idea on it. You say DFA can only take one path through the state graph. NFA can choose. We're still on lexical analysis. NFA can choose whether to make epsilon transitions or not. So this one is allowed to choose. Sometimes your NFA will not have that, but you guys you're going to use something called Thomson construction. So you'll always have it. You'll always have the epsilon transitions, because it's going to be something like this: epsilon, epsilon, epsilon. So this will be the format. 1, 2. Just sketching this quickly. Yeah. For the sake of this class, that you understand of this record. So you must know that you guys will be having epsilon transitions. Your NFA will always have it, unless the lecture says you should not do it in that way. Then now you have a transition diagram of an NFA. So they're saying what language? Okay, let's first check this. I think this is equivalent to that. So this is a regular expression. This one is a transition diagram. So here's the explanation. This transition diagram, it allows you to repeat on state 0, to repeat either A or B. Hence you see here you have got epsilon AB. See, comma. You have AB, AB. You have AA. Then it can take an A and another A. So these are the possible combinations we can have. It can have AA, AB, AB, can have BA, can have BB, can repeat. Remember, even here, on the first state can repeat BB and then it stops, it ends. Oh, actually, this is the combination. I think here it's a matter of how they wrote it. This is the combination that they wanted to write. AA, our string will always end with AB. It will always end with AB. Our transition diagram, sorry, it is string. So now the combination will be AA, AB. So the red one will be my A, the one that it ends with AB, AB. So I'm writing the possible combinations BA, B, and then you can have also BB, BB, AB there. A. And then another possible combination is this one. You can have triple A's, but you must end with A. A, A, B, A, B, A, B, A, A, B, A, B, B, A, B. You see, this is quite simple, guys. Just have to analyze your A. So all this, you are always ending with A. So now I'm moving to another part. Here they were giving draw an NFA. So as I said, you are going to draw an NFA using what we call Thompson construction method. So you'll have a start state. You'll have your epsilons transitions here. Then you have what. Then here you'll have your end state. So therefore, this is the format. One, okay, usually one this side, 2, 3, 4, 5. It is usually like this. This will be the format. But with this question, they say draw for that. Ne? So we can have epsilon transitions, we can have A. So another property of NFA that it can have multiple end states. So that here it ends at here's our end state. So an end state on a transition diagram is represented by double cycles. What else do you guys have to? Then BB. So this it allows the repetition of B's, ne? And this one it accepts A's. Hence we have this. AA means we can repeat them as many times as what, and the BB. But take note, when it's like it's here, we're only repeating those letters, those specific letters. So now I'm going to move to something. Okay, let's check this one. Here you are allowed to repeat A or B, and then you are what will always end with A, B, B. So you must just learn how to draw this. Then there's a transition table of an NFA. So when you're on state 0, we check what will be the input, what will be the state that you will get when you input A, right? So you'll get, for input of A, when you are on state 0, you can either go to state 1 or you go back to 0. So hence you have 0, 1. For B, when you are on state 0, you can only go to state 0. Hence you have 0. So here they were saying epsilon, right? So we don't have epsilon transitions, hence everything's like that. So now we also have, when you're on state 1 to get an A, you can't. When you're on state 1, in order to get an A, you won't get an A. When you're on state B, when you're on state A to receive a B, where do you go? You go to state number what? You go to state number 2, as you see here, hence it's 2. When you're on state 2, A, there is no A, but you can input 3. And here, this is the end state. It will always be like that, 0, 0. So when they say draw transition diagrams, I don't expect you guys to get this wrong. This is quite simple. Let's get total. So here they were saying indicate all paths leveled by indicates consider this, and does the NFA accepts AABB? Does it? Obviously, I think the answer here will be yes. Indicate all the paths. So when they say indicate all the paths, I think they want you to indicate either with this transition diagram, you redraw it, or you level the states. Let's check. You can have an A and another, you can have another, if they said AA. So I'm just writing the states. Then BB, where we will receive B, and B will receive it on number 2 here on this part, or on 1 1. So here there are a lot, I think there are a lot of possible combinations. 1 1 0 0 1 1, or you can have 0 0 2 2, but you must also check, you must also consult with the lecture on this one, that you're also sure of it, because I think this was there on this other question at 6 marks. You are looking for AABB, and then we can have an A and an A, then here it repeats. So this is the other combination, 0 1 2 2. Or you can say 2, so that 0 1 2 3. Sure. But you will move from, let me explain the 0 1 2 3. You'll get an A. You can get an A at state 1, and then you can receive it and another. Okay, this is wrong. I said 2 0, oh 0 1 2. Okay, on state 2 you can receive a what? A B, because you have a B there, and then here you have a B. Yeah, so I wrote this one, so you guys, you should also check the other possible combinations here. And I'm not supposed to say 0022. Let's avoid this one of 0022. Yeah, let's avoid it, and let's check. I don't want us to say 00. We can say 0. It can take an A here and another A. Okay, this one is the only one I can think. Okay, yeah, let's repeat. I think we can repeat 1 0 1 1, and then we say 2 3. Yeah, you can also check with this one. I think this one is also correct. I just wanted to have only four states. I wanted it to be strictly 4 states. So, but you can also consult with your, like, if you're allowed to do this, to repeat the state there. But I think this is the only tricky thing. And then we go to other parts now. We have what we call DFA. It's a special form of an NFA. It has no epsilon transitions. So I don't want you guys throwing epsilon transitions for this. So even here, you must know how to draw a what? You must know how to draw a transition table. So this represents a transition table for this diagram A. So they are saying when you're on state 0, you can receive an A, an output of A 1. So let me just draw it here. A B 0 1 2. On state 0 to input an A, you'll get, we move to 1. To input a B, you move to 0. To input, when you're on state 1, you go back to 1, and then here you go back to 2. When you're on state 2, you will receive an A. Let me remove this. Yes, we'll receive an A from state 1. We only receive a B. Okay, there is an error, right? Let me just check. Oh, okay, it's fine. Yeah, we go to, when we're on state 2, we go to state 1. So hence they wrote 1, and then to go to, and then the input for B, we go to state 0. So this is how you must draw a transition diagram. It's the same way, it doesn't change for all diagrams, whether it's an NFA or so this is the Thomson construction. Then let me move. You guys will go and learn how to do this. This is quite simple. I'm gonna skip this for now. Okay, unfortunately, I won't explain this for now. I'll just leave it because I don't want you guys to feel like this is too difficult. Yeah. Then let me go to the second part. We're done with synthetic now. We'll go to syntax. Syntax analysis. Remember this one we are dealing with the design, with the syntax. We check the syntax if it's correct. Okay. So they say every language has rules describing the syntactic structure. So let's check the important parts that you must know for your test. We have a term called error handler. They say a good compiler should assist in identifying and locating errors. This is true. Lexical errors, we have synthetic errors, semantic and logical errors. So you must know this. Compiler can easily recover and continue. And then syntax errors, a compiler can almost recover misplaced semicolons. So some compilers, they do fix your errors, right? They allow you to continue even though there are slight errors. And then semantic, let's see, can sometimes recover. And then logical. So these are the types of errors that the compiler is going to help you to know. Sometimes you'll see when you're on VS Code, you'll see it tells you you have misplaced a semicolon, and then sometimes it tells you an extra braces. It gives you a hint, right? So these are the types. So just know if your error it says as a missing braces, it is called synthetic. If it is missing what comparison is recover and continue spellings. If you misspelled a word, it can help you out, right? Identify it. Logical, hard or input. So with this one is tough to if your logic it's wrong, sometimes it's tough. You just get the wrong output. So we have got other terms here. So this you'll go and study. Just your I'm skipping this. Then we talked about passing. We said we have left top down passing and bottom up passing. I'm not sure if they have done an example here. Yeah, they have. So you guys, you must know now the difference. Check to basic generate LLLR. Okay, so this is the difference here. We have top down passing. So with this one, we're going to move from, I just want the definition, they wrote it. Okay, we have what called, I must start here. Right? Derivation is a process that generates valid strings with the help of grammar by replacing non-terminals on the left. Then they say we have what we call a leftmost and rightmost derivation. In leftmost, the leftmost non-terminal is always chosen first for replacement. So you must know that this, when we say leftmost derivation, we're talking about top what? Top down passing. Then with rightmost, we're talking about right view. We're talking about left right passing. Bottom up. Yes, we are talking about bottom up. Hey, terms. Bottom up passing. So hopefully guys will know for rightmost, you'll be replacing your values starting from the right, going this side, and then here, going that side. So let's check what's happening. We'll be replacing our strings. So they say two basic requirements for a grammar are to generate a valid string and to recognize a valid string. Consider this grammar. They wrote this for us. So to generate a valid string from that, so we're going to start from, because we're still on the left most derivation. When they say LL, just know it's left most. LR, RR, what LR, right most derivation. So they are the opposite of each other. So here you'll stay, given this example, right? ID plus ID times ID. Ne? So this is the input string. You are going to convert it into what? Into production rules. You are going to have the E, means we're going to move from left on this side. Hence they call it the leftmost derivation. Let me come and write left. Yeah, they already wrote for you guys there. Leftmost derivation. So I'm going to quickly move. So given that input string, so you'll start by replacing on the left. You'll first say E plus plus. We are not going to apply both parts here. You'll take this part, then is this part. The next part, you add the multiplication, isn't it? You have E times E. The next step is to replace there with ID. The last step, this one is our last step. You replace everything with ID. So what we are doing is what we call leftmost derivation. So this happens in a compile, and we've got the left right passing. They see what we've got. Okay, I've moved too fast. LR. Okay, let me copy that example here. When I copy this example, then I explain it. ID plus ID times ID. Okay. And I paste it here so that I can explain what they were doing here on this part. Resize. So we have ID plus ID times ID. So you're going to start like this. This one, it has negative. I don't know why it has negative now. They changed the question. Rightmost. Let me try to see what happened. I think there was supposed to be an example there for that, because we have a negative there. Production rules. Okay. Let me see. Okay, so with the rightmost derivation, you are going to start replacing from that example ID plus ID times ID. You'll start replacing from the what? Well, it was it like this? Yeah. You're going to write E. So you're going to only start like this, né? A plus E. E. You must replace this with E. This is expression. Remember, E represent expression. So you're representing a given expression with E. Then you have plus E times E. Then you apply. This is where you apply. You go back. You apply what you call right most. I think it explains itself. Hence, while you are going to come here and say ID, E plus E. Then here you are going to have E plus ID times ID. And then we'll have the last part is simply ID plus ID times ID. Yeah, guys will forgive them writing just so that you understand the difference there. Then this is what we call, there's what we call ambiguity. It's a grammar that produces more than one past three. For some sentences, it says to be ambiguous. You can draw a past three in different ways. For this sentence, they decided to draw it in this way. For that expression, the ID plus the same one we're discussing. So they will represent each expression. Obviously, the first E is this one. Then here you have E plus E. It represents ID plus ID. And then now they change what? Let's check. They change this to ID. And because they're applying the left, remember, this is where they apply the left most derivation. So you can have a syntax tree that represents the rightmost. So obviously the rightmost, you're going to start substituting this side. You're going to start this side. You will say I did that side. I think there is another past three here. I think it's this one. You see it? Here you apply the rightmost derivation. Then you have E plus E ID. Then the last step is ID. So both syntax trees are correct. So we also have what to call, okay, I'm gonna skip this. I'll explain some of the things when we meet. Because with the syntax tree, this is a syntax tree for this expression. I think it's correct. So, and also this one, it says syntax tree for this Java statement. Let's check it out. It's a plus 3 less than 400, which is this part. If, then here you must say if. Let's check our condition. If, and this will only be true if a is equal to 0. Then this other part is the else. So this is the if. Let me do it like this. So this side is your if condition. Then this side it's your condition, right? Here is the if part. Then you know to write the your condition. Then this is your code. If a is 0, else. Oh, this is the else. It's not the else part. Else they were saying b is equal to beta a times a. So you must just know how to actually draw this syntax tree because they can bring this question on a test. And they say draw a syntax tree for that. You should also try to do this. Construct syntax tree for the following. They give you something like that. For now, I'm gonna skip this. I think for today, I'm gonna stop there and go to data structure. Remember, I said this will also include data structures. So single dimensional arrays, I've already told you guys that you declare the same way. So this is the syntax, right? Public in Java. It's public class, then your class name. If it's array, you'll say array. Let me just call it class for now. Class. And normalize writing it. Public static void. So this is the basic syntax. Public static void, and then here you'll say, so this is our method, and then you say the method name here, method parenthesis, and then string args. So this is where you declare our data types. It's fine, and then we close it. You see, so that's the basic. This is the syntax. Java. So now, declaring an array, you're gonna come here inside your method, This is where your code will start. You will have int, then you declare your array. So I said this is how you declare your array. It's no longer C++. This is Java. You will say array. That's the array name. And then you do it like that. So if it was multidimensional, it will be int array. Then you put whatever there. See, this is very easy. Then we go to, let me check. Yeah, this is the first slide. They were saying creating arrays. Ne? So let's check with this. You can say array ref var, a new data type, array size. Let me see what they were doing here. My list is equal to new double pair. So this is the array name. You see, ne? And then, oh, this is like a variable. I said that's the array name. So this is our array name. So you are having array. So they were creating an array. We have declaring, right? Let's first check. I skipped there so I can see that. So this is the syntax. The data type int, you can say int, and then array name, ne? Array name. So this is how you declare. Meaning, yeah, something like that. That's how you declare an array. So I was saying you will have, if you are using double or float, you can say float, put that. Then here you can say, let's say your array name is data. So they're saying this is allowed. The way you guys are used to, ne? But it's not preferred in Java. Okay, so this is still allowed. And then if you have 10 elements, you can still put 10 there. Then creating arrays. There we're declaring, now we were coming to creating an array. Here we're having array name. Okay. So here, remember this is on a line of code, ne? You can initialize now your array name. You say new, let's say int. Then this is what this is another side. That's the syntax that you guys, I think you are used to. Then 10 array size, ne? So you are allowed to say your array name. You write your data type. Then obviously I think on the next line you're gonna do what? Declaring and creating in one. So this another style is they are showing you different ways of declaring an array, right? So let me just check here what they will do. Okay, this is when you reference the first element is the array name, index name. This is when now you are referencing your elements. And remember we index starting from 0, 1, 2, 3. So this was going to end at 9. Then you have 10 elements. Remember with arrays, the first element is represented by 0. Then here you are declaring, you are creating an array in this way. Array name is equal to new int 10. And then this is an example. Then this is another style of declaring, but here you declare and create at the same time, ne? In one step. So we can have one example. Okay, they do an example here. They just say it data type, we'll just create our own. Then here you have array name. Just say array. Array. Say array. Just use plain. Then this will be new, say new, here you write your data type. So here you're declaring at the same on the same line, you're doing everything on the same line. You're declaring and creating in one line. So it's nothing int and this is what we call declaring and creating an array. Here's an example. The same way I did, you see, double data type array name, then you say new data type and then write the array size. Then if you want to index your elements, you'll do such. And then if you wanted to list your elements, you'll say my list, because now your code already knows what's happening. Then you'll have 1, 2, 3. You can initialize your element, but make sure there are 10 so that don't have an error. 6, 7, 8, 9, 10. Then this you can write it on the next line. So we'll do this in a code as well. But I think we've already done arrays. The length of an array, they say, and once an array is created, its size is fixed. It cannot be changed. You can find its size using array name dot length. So when you want to know the number of elements, you should just do this. The code should print out. You just say system dot print out this net. Then let's see. Here they said my list dot length. Then on the next line of code, you're going to say return 10. Just because the way they structured this is not appealing. Then here you'll say array name. Remember on this slide, my list they use it as your array name dot length return 10. So this is when you're doing what? So your code you'll use this as a way of referencing your array. Because if you just say return 10, it won't know what's happening, but you must first write this. If you want to output the number of elements. Indexed variables. Okay, this is when you are indexing variables, you are just adding. You are adding the number that is on 0, 1, 2. Element number 3, you are adding it with element number 1 and 2. See, yeah, I'm sure this you guys already know how to index. This is how you initialize. We've done this in a code. Declaring, creating, initializing. I think this we have also done as well. Here you're just initializing your elements one by one. So if you didn't know, you'll just say array name. Here you index your values on this part. So we'll do this in a form of a code so that it makes sense. Double, you see here, you're creating an array and initializing it. You create and initialize your array. So the syntax is like this. It is data type. Here you already know, and then here you just say new data type, 4 elements. Just let your this is how you initialize. How many elements are you having? You are fixing your array to the number of elements you are having. This, when you do this, you are avoiding the error called index out of bound, right? It helps you in terms of getting such errors. Okay, I think this you can just go and also check out what's happening here. So here it's creating a for loop. So okay, let's just check. We've got 5 elements. So for the condition int I less than 5, as long as our program has got numbers which are less than 5. So let's see. So I think the output will be this. You'll have zeros, ne? Because your code is going to say I minus values I minus 1 is going to decrement your values as long as your I it's less than 5. Let me see what happens here. Values I. Okay, this one will have to do it in a form of a code. Okay, the thing after the array it's created 0 0 0 0. You should also try to put this one on a code and see what will be the output. Ne? I becomes 1. Okay, this is an explanation. Let me check. I is less than 5. I already know. After this line, I is 1. After the first iteration. Okay, so they are saying after the first iteration, I will become 1. Value 1 is 1. Value number 1. So I want to see how they actually got this. First value, remember we initialize the I to 1. So it's 1. Know that I is 1. I minus 1 is 0. Okay. Then the second iteration. Let me check on the second iteration. Okay, since we are incrementing, the second iteration will become 2, right? It will be 1 plus 1, 2, 1 plus 1 plus 1, 3. So the output for this program will just be 1, 2, 1, 2, 4, 1, 2, 3, 4 until, yeah, I think it will end here. The longer output 1, 2, 3, 4. So I'm looking for where they actually stopped. I becomes 4. No, this is okay. Go back. We must check also, we must also consider this part. Ne? I is still less than 5. After the second iteration, you have 3. Okay, the first iteration, you're going to have 0, 1. You'll have 0 on the first. It means your program is decrementing. I minus 1. Okay, this is the first. The second. I becomes 3. Okay, with this code, I think I'll have to also write it down because this presentation is not making any sense. After I plus plus, I becomes 2. Oh, okay. It means this code, at first, you are having I is 1. That will be the first iteration, right? Because it will be, yeah, that's why you have 1. But on the second iteration, you are having 1 plus I became 2. 2 minus 1. I think it's 1. It should be 2. It should be 2. So they're getting 3. I'm seeing 3. I is less than 5. It's like we're incrementing by 2, but it's fine. Let me leave this program. We'll write it on a code and do it. Okay, let's come to this. Initializing arrays with input values. So you guys, you have to know how to create a scanner in order to input values. So this is the syntax, java.util. So you must include this in order to start using scanner, right? Scanner input, then you'll write this new java.util scanner system in. It's just the syntax. And system out print. If you want to print, enter enter 10 values. If you want to enter, you want your program. So this is a program whereby it's going to allow you to enter 10 values. You're going to have value number 1, 2. You're going to enter 10 values on your code. So this is a for loop. This is an array. You are initializing it like this. And then when you say input dot next double, this is a method that allows you to go to the next input values. It will allow you to put the next value until you reach 10. So it's very important to know how to create this for loop. See, so system.out. Okay, let's check. This was just initializing with input. So this one is initializing arrays with random values. This one was with input values, normal values. With random values, you will use this function. So this can also come as a form of a replace. They can say replace with the right function. So sometimes you'll have to say input dot next int. You see, even this is still correct. Just that when you use double, it allows you to also put integers which have got the same as. Then this one will take care of all the random values. So we must try to write this code and check if with this one, what kind of values are you going to actually get. Initializing arrays with random values. So here we're saying multiply by 100. It means this code it will allow us to substitute more than 10 elements. Let me see. Okay, this is a way of summing elements in Java. You'll do it in that way. So remember, this is the array name. So you must do this when you create on your condition. It must be array name dot length, so that you don't get what an error. Your program must know that it must not exceed the number of elements. So that's how you must write the condition there. Then here it will sum. If your array had, here they're using my list. If you are having int my list, if you initialize it, let's just say 246. Your output is going to be 12. Finding the largest element. So you must also know how to find the largest element. With double max my list. And then you must create a nested what? It will be a for loop. And then inside you must write a condition because you want to find the largest element on your code, right? And then here you'll just say you must first start by declaring the maximum variable. You initialize it to the first element so that it can compare. It is going to check the first element if it's greater than the maximum value. When now it finds that the first element on your list, it's going to first compare the first element with the next with the maximum value on your array. Then when it finds that it is greater than, when it finds that your first element is greater than, let me first write this 2, 4, 6, 8, 10. If 2, it will first check is 2 greater than 4. If no, it checks the next one, checks the next one, checks the next one. So when it finds the one which is great, 6 is greater than 4, right? But yet the maximum value no is 10. So when it gets to element number 0, 1, 2, 3, 4, so at least 4, my list 4, if it's greater than everything there, you know that the maximum will be. So usually you can also first initialize this one, initialize these two 10, but already your array knows that that is number 4. So it will just compare, and then if it finds that the first element is greater than everything, usually you will assign, so that this code works properly, you will assign the first element to be the largest one, so that you can be able to actually understand this one is your maximum value. It's your maximum. So if 10 is equal to 10, which is my listed I, you see, it will be the maximum. Hence you must initialize the first element as the maximum. It's a code just to find the maximum value here. There is nothing difficult. Then we have what to call random shuffling. We are shuffling elements, rearranging them, right? So you must have a for loop. You must also have a function that will swap those elements. Swap lines. Okay, this one will do it in a form of a code, because shuffling it's also something related to, remember we said we must do linear search and sorting. We said we'll do searching and sorting all in all. I already gave you guys a codes based on this, but we didn't do shifting, so we'll do it. We'll not waste time explaining codes line by line. Take time. Looking for something that okay. We also have a code for traversing elements, for reversing elements. So your output should be the other way. It should be 6, 5, 4, 3, 2, 1. So it's going to reverse this element. So you must also create a what? You must declare a what? A function that will reverse. It will say reverse array name. So reverse array. Yeah. And then you'll create. So you're going to first declare this before you create your what? Before you start writing your code. So this is where the code starts. Your array, you initialize it. It's either you initialize it here. So here they initialize the array length. They didn't do it inside the for loop, because inside the for loop they want to use that maybe the last element to decrement it and check. It's either it decrements or something. You must just analyze this code properly, right? It says on the for loop you initialize I0 j result dot length -1, I is less than I plus plus j minus. So you see j, it's another variable, maybe it's representing this part, so it will decrement, so must reverse, hence you have got that function. So the condition will be this one: the results of j when they are equal to, yeah, so it will compare if 5 is equal to 6, which is not. So it means if it is not, it will return. Obviously these things, they are not, those numbers are not equal, so all of them, they are going to be reversed in that order. So you must just know how to actually create those two variables and this for loop there, because you must write it in full. For loop, for into int I0 j array name dot length -y -1 when I is less than length, keep on increasing, they will keep on decreasing. So I, obviously it will start here, and it represent the last element going down, because no, it represent the first element going up. J is there. It will be comparing between j and I. That's what most of this program will be doing. You must just know how to write them. Because if I explain each and every code, you won't even write the code down. You see, now, so these elements, they represent I. Because if you check it, they say I is 5. When I is 5, it will compare with 6, isn't it? So we must just analyze this. Then we also have the linear search. So this is how you must write the code. This is where your code starts. Then here, this is your method, linear search. And then here inside, you'll say int. Then here you would have declared your array here, int up here, list. See, and then you're going to have that. And you also declare your array. Actually, they've already declared. You don't have to write that down. And then you'll say create an if the value you're looking for. So key is the value you'll be searching for. If it is equal to the what list at I. Okay. If it is equal to that number, it will search through your array. Your program will search through your array and check if they are equal. It will return what? It will return I. It will return that number on your array. Return I. So this it needs us to also write it down because so that it doesn't get confusing. So the binary search checks the side, this left and also the right hand side, right? So I also wrote the code for it. So I will try to explain this when we meet. The sorting, the searching, and search. So I think on the next class, we must also check the multi-dimensional arrays. I'll do a recording. I'll try my best to explain this because if I explain it all at once, it will become a mess. So we'll end the session here. We'll just end the session here for now on single dimensional arrays.